all, in this video I am going to explain how to match the roots with this impulse response. First, what is root? How to find out the root? The characteristic equation in the denominator polynomial is equal to 0. We get the root of the characteristic equation. So n of s is the numerator polynomial, d of s is the denominator polynomial, that is equal to the transfer function. D of s is equal to 0, we get the value of roots. A single root at the origin. Single root means only one root at the origin. So s is equal to 0. S is equal to 0. How to represent the transfer function 1 by s? Next, I am going to find out inverse Laplace transformation of 1 by s. That is equal to 1. How to draw the impulse response? The response is the unit step response. Impulse response, that is the unit step response, h of t equal to this one. And next, B. Single root on the negative real axis. So this is the negative real axis. For example, I have to consider the root as -1. Next, I am going to write the transfer function of this equation. Tf is equal to 1 by s plus 1. Take the inverse Laplace transformation of 1 by s plus 1. That is equal to e power minus t. Here t and this is e power minus t. First put e power t is equal to 0. So t is equal to 0 means e power 0 is 1. Then t is equal to infinity. T is equal to infinity means what? E power minus infinity. So what is e power minus infinity? That is 1 by e power infinity equal to 1 by infinity, that is 0. Okay, a single root on negative real axis is equal to option number 1. Then C part, two imaginary roots. So two imaginary roots, here you have to consider as this is j1 and this one is minus j1. And how to write the transfer function for this? Transfer function is 1 divided by s minus j, j1 or j. Here s plus j. That is look like a minus b into a plus b. So it is a square minus b square. A square means s square minus j square. So j square is minus 1. So minus into minus 1 plus 1. So what is the Laplace inverse of this? 1 by s square plus 1. A by s square plus a square, that is sin at. Here that is a is equal to 1. So sin t. So what is sin t here? 2 imaginary root. This is the sine waveform 4. And the last one is two complex roots in the right half of the S-plane. See, two complex roots, right half. Have to take the complex roots, one of the root as minus 1 plus j. Next is minus 1 minus j. How to represent this? Here this is S or sigma, here omega. How to write this? Minus 1, that is real. So minus 1 plus j. This is minus 1 plus j. And here minus 1 minus j. Okay, how to write the equation? Transfer function Tf is equal to 1 by s minus of minus 1 plus 1 minus j. Then s plus 1 minus j plus j. Minus of minus 1 plus 1 minus of minus j also plus j. Here you have to apply the a minus b into a plus b formula. That is a square minus b square, s plus 1 the whole square plus 1 square. So what is the inverse Laplace transformation of this? So inverse Laplace transformation of this one is e power minus at into sin at. This is the normal formula. Instead of a, we are having 1. So e power minus t into sin t. So how to represent this? This is the increasing exponential. This first one is the decaying exponential. How to represent this? First of all, have to draw the increasing exponential. So first value is 1 and the value is increase, it will become increase. And here also we'll get the increasing exponential. Now I am going to draw the sine waveform. Both are multiplying together. Okay, I have to draw the sine waveform also. Increasing exponential and sine waveform look like this. So this is the sine waveform. So two complex roots in the right of the half of the explain, that is 5. So which one is correct answer? Option D is the correct answer. Thank you. Have a nice day.